All right, this is a video tutorial of the 3.3 section of the geometry textbook, Proofs with Parallel Lines. Your three learning objectives are you can use the corresponding angles converse, you can prove theorems about parallel lines, and you can use the transitive property of parallel lines. So the first thing we need to go over is related to the last section from 3.2, but it's just the converse. So it's just changing the order in which we are looking at the theorem for corresponding angles. So in the previous section, the theorem we talked about was if two parallel lines are being cut by a transversal, then their corresponding angles are congruent. This one is just a converse statement. Remember back in chapter 2, we talked about converse, which switches the hypothesis and conclusion. That is what this one is doing. So instead of starting with the parallel lines first, you are starting with if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So you're starting with the given fact that 2 is congruent to 6, and because 2 is congruent to 6, you can then prove that line J is parallel to line K. So let's go ahead and find the value of x that is going to make m parallel to n. That is what that symbol says. So the way that we set this up is first, we're going to assume that lines m and n are parallel when the marked corresponding angles are congruent. So as long as those green and purple corresponding angles are congruent to each other, then we can say that the lines are parallel. So we're going to create an equation that sets those two angles equal to each other. 3x plus 5 equals 65. Then using algebra to solve for x, you're going to subtract 5 on both sides to get 60. Then the opposite of times 3 is to divide by 3. So the value that makes those two lines parallel is x equals 20. If x was anything else, then those two lines would not be parallel. Similar to the other different types of angle pairs we talked about, these converses can work for both alternate interior and alternate exterior. So if you're given two lines that are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Same thing with the alternate exterior. If you're given a diagram and you know that the alternate exterior angles are congruent, then you can say that the two lines that are cut by the transversal are parallel to each other. The last one, same thing, consecutive interior angles, but remember these ones are supplementary. So if angles 3 and 5 add together to equal 180, then you can say that the lines are parallel. So those are your four converse theorems. Very similar, in fact, almost identical to the 3.2 theorems, except they're just converses. So you're switching the order of the parallel lines and then saying if the angles are either congruent or supplementary. So let's prove that if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. This is your proof of it. So let's draw a diagram. We have two lines, G and H, that are being cut by a transversal. It's going to create different pairs of angles, and these first two that are marked here, 4 and 5, are alternate interior angles. They're both on the inside of your G and H, and then they are on opposite sides of your transversal, hence the alternate. So you have your green and your purple angles right here. That would be vertical. So these two angles are vertical. Then switching it up, you could have corresponding to those. So if you can say that 4 and the purple are vertical, those two have to be congruent based on vertical angles. And then the congruent one from purple to green would be corresponding angles to get your 1. So if you are given that angle 4 is congruent to angle 5, but you have to prove that the two lines are parallel using your converse theorem, we're going to create our two-column proof, statements and reasons. Always start with your given statement first, and your reason is just given. So since you go from there, angle 1 is congruent to angle 4 based on the vertical angle theorem. This one just says vertical angles congruence. If you just say vertical angle theorem, that would also work. And then 1 is going to be congruent to 5 based on the transitive property of congruence, because if 4 is congruent to 5, 1 is congruent to 4, connect the two dots, 1 is also congruent to 5. Based on that, you can say that G is parallel to H based on the corresponding angles converse. So now let's look at the diagram with a couple different transversals but still looking at only one pair of parallel lines. So the only thing that is marked in this diagram is line R is parallel to line S. We have to prove that P is parallel to Q. We don't know that it is because it's not marked that way on the diagram. So we're given that R is parallel to S and that 1 is congruent to 3. We're going to look at the diagram and we're going to make a plan. So the diagram suggests that we're going to look at both angles 1, 2, and 3, and we may be able to focus on just one pair of lines and one transversal at a time. So it kind of looks like a tic-tac-toe board right now. But if you imagine only looking at RS and Q, that will look at your 1 and 2. And then if we look at PQ and R, that would help us with pairs 2 and 3 for our alternate interior angles. So it's going to depend on which one is going to be our transversal. Remember, it's the one that cuts the other two lines. So if we're looking at just angles 1 and 2, that means we're looking at R and S as our parallel lines and Q as our transversal. So 1 and 2, based on that setup, are marked corresponding angles. And that's why 1 is congruent to 2, because we already know that those two lines are parallel. Next, we're going to look at angles 2 and 3. Now this is going to switch up which lines are our potential parallel and which one is our transversal. So we're looking at P and Q as our lines and R as the transversal. Well, 2 and 3, based on that scenario, are alternate interior angles. So if those are parallel, then 2 is congruent to 3, okay? Assuming that P and Q is parallel. So how we're going to go about this, it's given to us that those two lines are parallel. R is parallel to S based on the markings. So based on the corresponding angle theorem, 1 and 2 are congruent based on the given information. It's also given to us that 1 is congruent to 3 from the directions from the get-go. So because those two are congruent, based on the transitive property, 1 is congruent to 2, 1 is congruent to 3, 2 is also congruent to 3, and then we can use that fact of 2 and congruent to 3 based on the alternate interior angle converse, hence P is parallel to Q. Okay, so transitive property being applied to parallel lines. If you have two pairs of parallel lines that are parallel, and then you have another two pair of parallel lines that are parallel, the first and the third are also parallel. So if P and Q are parallel and Q and R are parallel, then P is parallel to R. None of those lines are going to be intersecting, and it just depends on which two you are looking at a pair of parallel at a time. So let's look at the flag of the United States. It has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. Well, if you label all of those stripes 1 through 13, each stripe is parallel to the one immediately below it. So 1 is parallel to 2, 2 is parallel to 3, 3 is parallel to 4. You can go all the way down the line until you get 12 is parallel to 13. So based on the transitive property, S is parallel, or S1 is parallel to 3 based on the transitive property, and then you go from 3 to 4. S1 is parallel to S4, and you're pretty much just connecting the dots of that reasoning until you get all the way to S1 is parallel to S13. So based on the transitive property of parallel lines, if each pair is parallel to the one before it, then the first one is parallel to the last one. And that is the end of the video.